I very frequently get asked. I would say every single week I go speak, which is 52 weeks a year now for 16 years. Every single week somebody will say, now Hovind, how do we see stars billions of light years away? You say the Earth is only 6,000 years old. How do we see the stars? Yesterday on the radio program, on the website, Dr. Dino, some guy called in and said, now, Hovind, I did some studies, and in a 6,000 light year radius, we'd only have so many cubic miles, and all the stars wouldn't fit. I said, wait. Who said anything about a 6,000 mile radius? He said, well, you're the one that said the universe is only 6,000 years old. Yes, I did. But I did not say all the stars are within a 6,000 light year radius. I've never said that. That would be ludicrous. But how do we see the stars billions of light years away if the universe is only 6,000 years old? And I believe the Bible clearly teaches it's only 6,000 years old. And God made everything. Actually, He made the earth first in Genesis 1. And then in verse 14, He made the stars also. Evolution says He made the stars evolve first and then the earth. Well, there's certainly a lot of stars out there. Nehemiah chapter 9 says, Thou, even Thou art Lord alone. Thou hast made the heaven of heavens. God is claiming that He made them. So, either He did or He didn't. But what about the stars? How do they fit in? Astronomers can see a star blow up about every 30 years. It's not like it's on a timetable. It might be every 5 years, might be every 50 years, but on an average, every 30 years, a star explodes. And they're looking out there with their telescope and say, oh, wow, there's a new one. A star exploded. It's called a nova. Or if it's a big one, they call it a supernova. Nova in Spanish means no-go. By the way, the Chevy Nova did not sell very well in Mexico for that reason. Hey, do you want to buy a Nova? No. Why would I do that? It won't go. But stars blow up every 30 years. Well, they've searched the heavens with these telescopes looking for how many supernova rings are there. They call it a dead star. Or they can find less than 300. Now, wait a minute. If there are less than 300 supernova rings, and one happens every 30 years, you can do the math. I mean, that's about 9,000 years. If the universe is billions of years old, there ought to be a whole lot more supernova rings out there. Why are there less than 300 supernova rings? Because it's less than 10,000 years old? Boy, they don't like that answer at all. But that's the logical conclusion. Anyway, if stars are blowing up every 30 years, we would have to have at least one star born every 30 years just to keep the balance. I mean, countries that have a population problem because they're getting less births and deaths, like Germany, more people are dying than being born. Oh, well, eventually that's going to create a problem, okay? Stars should have to be born. Nobody's ever seen one star form, not one. We see them blow up all the time. They've never seen a star form, and I'll cover that in a second. Its last estimate by Hubble telescope was that there are 70 sextillion stars. 70 sextillion. They say the universe is 20 billion years old. Well, you can do the math. That means 6.5 million stars would have to form every minute. We'd have to have 6.5 million stars forming every minute for 20 billion years to make the stars that we know about. It doesn't count the ones we don't know about because we can't see them yet. Who knows how many stars are out there? Sometimes the textbooks will say, well, there are new stars being constantly born in clouds of gas and dust. This is so stupid. How a physics textbook can teach this, I don't know. Anybody that knows freshman physics knows when you try to squeeze gases together, pressure builds up, temperature builds up, and it drives them back apart. It's called Boyle's gas law. Nobody has ever seen dust collapsing into a solid. It would take such incredible pressure to do that. I was in a debate one time, and this professor, I asked him, I said, how can you get dust to collapse into a solid? Explain that to me. He said, well, we calculated that if 20 stars explode near each other, it'll produce enough pressure to make a brand new star. I said, now that's brilliant. You got to lose 20 to gain 1. I said, you ought to run for Congress. You could help those guys borrow their way out of debt, It's not going to get a universe full of stars if you got to lose 20 to gain 1. And even that is only theoretical. It's never been observed, okay? I was in Alamogordo, New Mexico, and they've got a science center down there, and they showed these pictures of star babies. They said, oh, this is a new star forming. No, sir, it's a bright spot, okay? One guy in Science magazine admitted, the silent embarrassment of modern astrophysics is we do not know how even a single one of these stars managed to form. Nobody knows how stars can form from dust clouds. No one has unambiguously observed material falling into an embryonic star, which should be happening if the star is truly still forming. and no one has caught a molecular cloud in the act of collapsing. Precisely how a section of interstellar cloud collapses gravitationally into a star, a double or multiple star, or a solar system is still a challenging theoretical problem. Astronomers have yet to find an interstellar cloud in the actual process of collapse. The origin of stars represents one of the most fundamental unsolved problems of contemporary physics. This guy said, no one really understands how star formation proceeds. It's really remarkable. Nobody knows how this happens. So if they tell you new stars are forming, you tell them Kent Hovind said they're confused or they're lying. Because nobody knows how it happens. There's not even a good theory how you could squeeze dust into a star, and there's certainly no evidence. But here's what happens. They see bright spots appear in the clouds. Or not in the clouds, in the dust clouds in space. They look at this Crab Nebula or Eagle Nebula, and they're staring at it, and all of a sudden one day a spot gets a little brighter. Oh wow, a star's being born. That's immediately their conclusion that a star is being born. I said, wait. Maybe the dust in front of it is clearing and the star was already there. Maybe it's a star blowing up. Maybe it's another supernova. Because that's what happens when stars supernova, they get really bright. They don't know that a star is forming. So don't let them tell you that we've seen stars form. Nobody has seen such a thing. All we do is we see them blow up, which is the opposite of what evolutionists need. Now, the Bible says in Genesis chapter 1, let them be for signs and seasons and for days and years, and he made the stars also. Here God is claiming he made the stars, and it says in Psalm, he counts the number of the stars. Not only how many there are total, but each one has its own number. So God will say, oh, this is star number 42 trillion, 718 billion. He knows the number of each one. And it says, praise him, ye waters that be above the heavens, in Psalm 148. This is the only verse that says anything like this. Waters that be above the heavens. Now in Genesis 1, it talks about verse 6 and 7, water that be above the heavens. I believe when God first made the world, it was very, very different than what we see. Mostly land, instead of the huge oceans that we now have. Most of that water was in the crust of the earth. We covered that in video 2. But there was earth and there was heaven, singular. King James is the only Bible I'm aware of that gets it right in Genesis 1:1, where it says, in the beginning God created the heaven and the earth. All the rest of them say heavens. Okay, that's a mistake. There was heaven, which means expanded place. There was earth, and then from here on out. Then he divides it up into 3 slices. First heaven, second heaven, third heaven. The first heaven is where the birds fly. Genesis 1 talks about that, verse 20 and 21. Then there was water above the firmament. Now, some creationists do not believe in the canopy theory. I understand. I've read their stuff. I think they're wrong. I still believe, and some accuse me, well, you don't agree with us, therefore, you're not a good creation scientist. Keep up on your research. I keep very much up on the research, and I disagree. It's not that I haven't read it, it's that I have read it and disagree. Okay? But I believe there was a layer of air for Adam to breathe, layer of water above to protect him, and then a layer of stars, and then more water. The only verse I have to back it up is right here, Psalm 148. Praise him, ye waters that be above the heavens. That's present tense. Is there still water above the heavens? Psalm 104 says, who layeth the beams of his chambers in the waters, who maketh the clouds his chariot, who walketh upon the wings of the wind. Could it be that there is another layer of water beyond all of outer space? Maybe everything that we see as this universe, which looks like huge, maybe everything we see is inside water, a crystal, and God is outside of that, the third heaven, 2 Corinthians chapter 12. Could there be a third layer where God lives? Of course, God doesn't need a place to live. He just is, Psalm 29 says, the voice of the Lord is upon the waters. The Lord is upon many waters. Maybe everything that we see when we step out at night and say, wow, look at all these stars. Maybe the whole thing's a little snow globe on God's dresser, that he picks up and shakes once in a while. How you doing in there? I don't know. I like to think that way. But the Psalm 148, the waters that be above the heavens, people have often asked, hey, where's the last star? And once we find it, what's on the other side? I don't know the answers to those, but just a possibility is that there, according to the Bible, may still be water above the heavens. But there's a lot of stars out there. Hubble estimate was 11 trillion stars per person. That is 76 trillion divided by 6 billion people. Every one of you gets 11 trillion stars. What happened, they told the Hubble telescope to focus in on a dot. They found a dot above the Big Dipper. You can see the picture of it there. It is about the size of a grain of sand held at arm's length. And it was black. They said, we don't think there's any stars there. Let's focus in on that spot and see what we can find. They took pictures for 10 days straight, focusing in on that dot. After 10 days, there were more stars in that dot than they could count. These were brand new stars, never been seen before. Called it deep field, Hubble Deep Field. Looking up there saying, man, that's stuff we didn't know about. Assumption would be that it's that way all through space. Truly, the stars cannot be numbered, which is what the Bible says. They cannot be numbered. But how do you tell the distance to the stars, and how can the Earth be 6,000 years old and the stars be so far away? Fair question. Stephen Hawking said, stars are so far away, they appear to be just pinpoints of light. We cannot see their size or shape. How do we tell different types of stars apart? For the vast majority, there's only one thing we can see, and that is the color of their light. If you get the biggest telescope on Earth, this is not it, by the way, spotting scope, but if you get the largest telescope on Earth and look at the closest star, which is Alpha Centauri, 4.5 light years away, all you're going to see is a dot. If I focus this in on the sun, it'll start to get bigger and bigger, and you can actually see flames leaping off and see the spicules, and you can see color changes, and you can actually see features of the sun. When you look at a star, you never get to see that. Nobody has ever seen a star as far as any of the features of it. You get the biggest telescope on Earth, it's going to be nothing but a dot in your scope. All you can tell is, I said, that's a red one, that's a yellow one, that's a blue one. That's all you can see. So anything we do, we have to do based on assumptions just from the color. But how do you tell the distance to the star? Well, I taught high school trig for years, and if you guys had trig, you know how it works. If you have 2 observation points, you can calculate the third distance. You have to know it. It's solving a triangle. Trigonometry deals with triangles, so you sine, cosine, tangent. If you know one distance and 2 angles, or two distances and 1 angle, you can calculate the rest of the triangle using sine, cosine, tangent. Here's the problem. Earth is only 8,000 miles in diameter, which compared to star distance is 0. It's nothing. So if I'm looking at a star and somebody over in China is looking at a star, we are 8,000 miles away from each other, straight line through the Earth. That would be nothing. What they've done to enlarge the distance to look at a star, instead of just being opposite sides of the Earth is also going around the sun in this great big huge circle. We're going 66,000 miles an hour, and it takes us a year to go around. Great big racetrack. Well, the distance from the Earth to the sun is about 93 million miles, average. And that's a lot, but at the speed of light, it's not much. At the speed of light, it's 8 minutes away. It takes the sunlight 8 minutes to get to the Earth. So if we're 8 light minutes from the sun, the diameter of our orbit going around is 16 light minutes. So what we're going to do is we're going to look at a star in January, and then we're going to look at the star in June, and we have now gone halfway around this monster circle. And we're going to get 2 observation points to try to enlarge the base of our triangle. And it sounds huge. Man, that's 186 million miles. Well, it's still not much. A year has 525,000 minutes in a year. If this picture here showing the little yellow dot was the scale, if that yellow dot represented Earth's orbit, not the Earth's diameter, the orbit of the Earth, it's way too big for the picture. What we're going to do is try to show you the math involved here. If I had 2 surveyors setting up with their transits or telescopes, and they are 16 inches away from each other, and they're both looking at a dot 525,000 inches away, which is 8 1/3 miles. Would you agree that would make a rather skinny triangle? Let's go out in the parking lot and draw a triangle with point A and point B 16 inches apart, and point C 8 1/3 miles away. It's going to make a real skinny triangle. That is exactly the triangle you get when 2 people on opposite sides of Earth's orbit try to measure 1 light year. 1. Now, and I'm not sure you can tell exactly where you were 6 months ago. I think that would be a little stretch of the imagination to say, oh yeah, 6 months ago in January we were, where were we? I'll give them that. I won't even argue that. I just would bring that up, for appeal, Your Honor, in case we need to. You can't know exactly where you were 6 months ago. But the angle you get with that is 0.017 degrees. Now let's imagine this. I want you to get two guys to set up their surveying transits. They're 16 inches apart, and I'm going to go put a dot 8 1/3 miles away, but they don't know how far away it is. They're both focusing in on the dot, and they see this dot out there. Here's the only information they have: the measurement between themselves, 16 inches, and the angle out of parallel. I say, guys, I want you to calculate how far away that dot is based on that little angle change you get. I think that would be difficult to measure. 1 light year. There'd be some guesswork involved, okay? Now, if you want to measure 100 light years, you got a much worse problem. Now you got to move your dot 830 miles away. If we had two guys on the roof of this building here in Pensacola, Florida, 16 inches apart, and they're both focusing on a dot in Chicago, which is 830 miles away, but they don't know how far away it is, they're going to tell me how far away it is, based only on their angle of their telescope out of parallel. I would say that's impossible. Impossible. To measure 15 billion, no question that's impossible. I don't think you can measure 100 light years. Not with real numbers, not with real measurements, but this textbook says they can measure, parallax trigonometry can measure up to 100 light years. Okay, I doubt it, but I'll give them 100. I'll give them 1,000 if they quit crying, okay? The fact is you can't measure 1 billion. Simple fact. So here's some things to consider about Starlight. It said in 2004 that the new SIM technology, Space Interferometry Mission, they hope to get where they can improve the distance of measuring to stars. And they say this accuracy will enable SIM to determine stellar distances to 10% accuracy out to a distance of 482,000 million miles. That's 82,000 light years. And then it says, this is an improvement of several hundred times over what is possible today. Well, now wait a minute. If they're going to improve it several hundred times, and it ends up being 82,000, what's 82,000 divided by several hundred comes out to be several hundred. Apparently they're admitting they can only measure several hundred light years, which I would agree. I mean, I would say that's even a stretch, but I'll give them several hundred. They can't measure billions, is the point. So when you students in school get taught, oh, that star's 14.629 billion light years away, I don't believe you. I don't believe you at all. It might be, but you can't prove that. They're making up a story. With SIM technology, they hope to finally be able to get out to where they can measure most of the way across our galaxy, and we're in it. We can't even measure across our own galaxy, let alone these distances to other galaxies. So I think we should look at the stars and say, wow, what a mighty God we serve. Instead of going out there and say, well, we know how far that way it is, we know it evolved. I mean, it's just that egotistical attitude some of these atheists get that makes you want to slap them in the face like, man, why don't you serve God? Look what he made, Here's the things to consider concerning Starlight. Then we'll take a break. Number one, we cannot measure these great distances. It just cannot be done. Number two, nobody knows what light is. They call it a wave or a photon or a particle. We know what it does. We use it all the time. But actually, give me a jar of it and paint it red. Nobody knows the substance of it. What is light? And we sure don't know that it always travels the same speed all through time or space. The entire theory behind a black hole is that light can be attracted by gravity. Well, if light can be attracted by gravity, then you cannot say the speed of light is a constant. Okay? At Harvard University back in '99, they slowed light down to 38 miles an hour. The next year, they slowed it down to 1 mile an hour. And the next year brought it to a dead stop. Light goes, pretty quick, 186,000 miles a second. They slowed it down. It was done at Harvard. It was done at Smithsonian. It was done at Cambridge University. A repeatable, demonstrable experiment. Now that is science. If you do an experiment, get a result, somebody else follows your data, does the same experiment, gets the same result, that's science. They slowed light down. This article came out on Fox News Channel. They said, we've succeeded in holding a light pulse still. They brought the speed of light to 0, brought it to a dead stop. Meanwhile, back in 2000 at Princeton University, they speeded light up to 300 times the speed of light. So when somebody says that star's 10 billion light years away, which I doubt they can measure, therefore that we can prove the universe is 10 billion years old, they got several problems in their logic right away that they probably don't see, which is why we do these seminars, so we can help people understand. It's 300 times the speed of light. Astronomer Barry Setterfield, Australian government astronomer, said, during the last 300 years, 164 measurements of the speed of light have been published using 16 different measurement techniques. The speed of light has apparently decreased so rapidly, experimental error cannot explain it. This is a chart showing the decline in the speed of light from the published numbers in the last 150 years. You notice the decline in the chart. The speed of light's getting slower until about 1960. For the last 40 years, anybody that's measured the speed of light gets the same number, 186,282.4, I think, miles per second. Who cares? Well, it could be that it leveled off in 1960 for two possible reasons. Three possible reasons. Our way of measuring is getting better. Instruments are getting better. We're smarter. You know, everybody in the past was dumb. We're smart. We got it right. Could be. That's what they'll tell you. Second option, though, is we're at the tail end of a logarithmic curve, and you're much less likely to see any decline. As you get further out on the logarithmic curve, it pretty much levels out. But a third reason is 1956 is when they invented the atomic clock. And they started using that as their clock to measure the speed of light. Well, now, wait. The atomic clock is based on the wavelength of a cesium-133 atom. So the clock is based on the speed of light. Now, if you have a clock based on the speed of light and you're measuring the speed of light with it, if the speed of light changes, you're never going to catch it with that clock. It's like watching two twins grow next to each other. Well, neither one's growing. Well, duh. You got a rubber ruler problem here. Clear back in '87, they said the speed of light was 10 billion times faster at time zero. There must have been a faster speed of light. There have been articles from the 80s, 90s, 2000s saying, look, the speed of light is not a constant. They said no physical law prevents anything from exceeding the speed of light. In two published experiments, the speed of light was apparently exceeded by as much as a factor of 100. The Big Bang Theory requires a much faster speed of light. Dr. Magluocchio, however you pronounce his name here, I got his book on the table. He says, a shocking possibility is the speed of light might change in time during the life of the universe. Could it be the speed of light was faster? Here's an article in the newspaper said, speed of light may have changed over history, study says. Winnipeg Free Press, nothing's reliable, not even the speed of light. We have shown that a time-varying speed of light could provide a resolution to well-known cosmological puzzles. One of the mysteries of a decaying speed of light seems to be able to explain why opposite extremes of the cosmos that are too far apart to have been in contact with each other appear to obey the same rules of physics, and even about the same temperatures. It would only be possible for light to cross from one side to the other if it traveled much faster than today, moments after the universe was created. Is the speed of light really a constant? There are articles here in Reuters News Service, the speed of light may not be a constant. I have dozens of articles like this in the last 15 years, and this will be much more detail in our college class about the speed of light. So don't let somebody tell you the speed of light is a constant. We don't know that. Big article came out in Discover magazine, says, was Einstein wrong about the speed of light back in 2000? He said, yeah, Einstein was wrong. The speed of light is not a constant. There's the book by the Italian scientist, I'm assuming he's Italian. It says, look, the speed of light is not a constant. And there have been many articles published about this. You can read them for yourself. I'll flash through them quickly here and you can get the details. So the third thing to consider, the creation was finished when God made it. Not only can we not measure those distances, not only is the speed of light not necessarily a constant, the creation was done. See, Jesus made wine out of grapes that never existed. He missed all that time. Instead of going from the water in the ground, through the plant, into the grape, squeeze it, make the wine, now drink it. No, Jesus turned the water straight to wine. What happened to all the intermediate steps? God can bypass all that. He doesn't need any of that. Okay? I ask people the question, how old was Adam on day 6? Anybody know? How old was Adam on day 6? 0. Did he look 0? No. He looked 52. 53 next month. But he looked perfect top, physical condition. God didn't make 2 babies and put them in the Garden of Eden and hand them a package of seeds and say, here, plant these quick. You're going to need supper. It has to be a full-grown man, full-grown woman, full-grown garden. They got to have supper like tonight, Better be something hanging on the tree ready to eat. Even if you plant a tree, you're going to take 4 or 5 years to get fruit off it. So the creation had to be mature. A fourth thing to consider about the speed of light question. A light year is a distance, it's not a time. It's a distance. And since the speed of light is not proven to be consistent, why would star distance have anything to do with the age of the universe? Now, I am not saying, and have never said, all of the stars are inside of a 6,000-mile radius of the Earth. That is not what I say. I don't know any creationist that teaches that. So when they say that, they're setting up a straw man, knocking it down. They're lying, basically. The stars probably are billions of light years away. They probably are. We just can't measure them, that's all. I like this article in the Discoverer. It said, how do scientists measure the age of stars? They said, well, we can find the absolute ages by comparing a star's color and brightness with those in stellar evolution models. What? We can tell how old it is by how old we think it is. That's exactly what they're saying right there. That's dumb, okay? Now, I think everybody's asking the totally wrong question. Everybody's saying, how did the light get from the star to the Earth? They're asking the wrong question. 17 times in the Bible, it says God stretched out the heavens. Well, if He stretched out the heavens, they're asking the wrong question. It's not how did the light get from the star to here, but how did the star get from here to there? That's the question we need to be asking. The Bible says pretty clearly God made the earth first, and then He made the stars also. And He stretched, suppose He made the earth, and then He stretched out the stars from here. Adam would see the stars on day 6, and day 7, and day 8. As the star is being stretched out into place, it's going to leave behind a trail of light. So the stars could be billions of light years away today, and still have been created in the 6 days, 6,000 years ago. Russell Humphreys has a book which I read, and I just have to say, I didn't understand it, all of it. He's really, really smart, but it's a good one on Starlight and time if you want to get more on that. I don't know that I agree with his premise. I think he starts with the assumption the speed of light is a constant. Now, how do we explain that? And they get into this warped space and bent space stuff. I think it's much simpler. The speed of light's not a constant, and God made things and stretched them out into place.
The real universe is the biblical universe. That's just the way it is. What about distant starlight? I want to spend some time on this one because this seems to be a big problem for a lot of people in terms of embracing what the Bible teaches. It really shouldn't be, but because of the weakness of our faith, sometimes we need a little more. Distant starlight really is not a problem for young universe. What I'm talking about here is the fact that we can see these galaxies that are billions of light years away. And when I use the term light year, that is a unit of distance, not time. A light year is about 6 trillion miles, okay? And so when I say the universe is billions of light years in size, that just means it's really big. It doesn't mean it's old. People hear the word year in there and they think that, well, doesn't it have something to do with time? Well, a light year is the distance that light under normal circumstances would travel in 1 year. And so you'd think if these galaxies are billions of light years away, that it would take light, billions of years to get from there to here. And obviously the light has got from there to here because we see them. And so doesn't that prove the universe is billions of years old? And this has come to be called the distant starlight problem. But I want to give you what I think is a solution to this. There's actually a number of different ways to resolve it, which is interesting. And of course, God has access to solutions that we might not have even thought of or even considered. He's not bound by laws of nature as we are. But I do want to point out that some of the proposed solutions really don't work. And I mention this because sometimes people will come up and say, well, have you thought of this? And yeah, we've thought of that. And there's a reason it doesn't work. Some of the simpler solutions that people think of really have been investigated and they don't pan out. The idea that the distances aren't real, maybe the galaxies are all within 6,000 light years, it's not realistic. Even our own galaxy isn't within that distance. These distances, I won't go into all the details, but there's good science to support the fact that these are at incredible distances. The idea the speed of light was much faster in the past, I think that was very worthy of consideration. I'm glad that they looked into that, but I think there's compelling evidence that it was not faster in the past. The speed of light is linked into other properties in nature. It sets the relationship between, for example, between electric fields and magnetic fields. It sets the relationship between energy and mass. And so if you tinker with the speed of light very much in vacuum, it might not even make atoms possible. So we like the speed of light the way it is. Light was created in transit is one that I want to spend a little more time showing you why I don't believe that's a good idea for starlight. People have pointed out, well, the universe was made mature in the sense it was functional. Adam was made as an adult. He didn't have to grow up from a baby. And if you assume he grew up from a baby, you'd conclude the wrong age by looking at him. And that's true. That's certainly true. And so people have said, couldn't starlight be that way? Couldn't it be that God made the beams of light, the star, connecting the star to the Earth? I think not. And the reason is because it would require God to create fictional images and movies. And I want to show you what I mean by this. Here we have supernova 1987A. There was a star in one of the Magellanic Clouds, and that little star right there in 1987 decided to blow itself to bits. Very sad, but it's a supernova. And so that star blew up. Now this star is in one of the Magellanic Clouds. It's over 100,000 light years away, let's say 170,000 light years away, something like that. And today, it looks like that. We see expanding star guts, what's left of the star expanding off into space. Now if you say, well, when did that happen? Now the secularists would say, well, 170,000 years ago, and the light just got here in 1987. And if you say, well, no, the reason we're able to see that is because God made the beam of light already on its way. When did this happen? Well, if you believe in light in transit, this didn't happen. It was just a picture that God made in a beam of light about 6,000 light years out that finally reached the Earth in 1987. If you believe in light in transit, this star never existed. That explosion never happened. And by the way, this doesn't exist either. These are just pictures that God put in a beam of light. And that really bothers me. It's not that I don't think that God has the power to do that. Of course he has the power to do that. The question is it consistent with his nature to do something like that? And I don't think it is. And I don't think God would create, light with fictional information in it, as it were. And if you say, well, I don't know, I think he might, be careful, because how do you know I'm here right now, right? I mean, how do you know God isn't making the light 1 inch away from your eye, an image of me? Well, we hear you too, no problem. God made the sound 1 inch away from your ear. No, I don't think that God makes fictional pictures for us. So if light in transit is true, then none of these things have ever actually existed. But we do see these things. And I think there's a better answer anyway. One of the ones that I thought was a little more plausible, I think it's not the right answer, but I want to mention it because at least it deserves consideration. Dr. Russ Humphreys has pointed out that time can flow at different rates under different circumstances. Einstein discovered that. And Humphreys says, well, maybe that's the solution to Starlight. Maybe that clocks on Earth tick slower than clocks in the universe. And I've chatted with him about this. It's an interesting model. I haven't seen the math work out in a way that actually solves distant starlight, though. But he continues to work on it, and it's interesting. I'm going to suggest that the solution may involve, I'm going to give you what I think the answer is. I think it involves the one-way speed of light. And that is the speed of light on a one-way trip, as opposed to bouncing out off a mirror, a two-way trip. The speed of light in vacuum is 186,282 miles per second, very fast. But that is a round-trip average speed. And what I mean by that is if we wanted to measure the speed of light, here's how we could do it in principle. We could build a very long hallway, okay, 186,000 miles long. We'll pretend we have government funding so we can waste it that way, okay? And we'll put it out there. And so I'm going to stand over here on this end with my flashlight. I'll have a mirror at the other end, or another flashlight, either would work. And what I'm going to do is when the clock strikes noon, I'm going to I'm going to turn on the flashlight for just an instant, send that pulse out, and it'll reflect back. And as soon as I see the reflection, I'm going to look at the clock and see how much time has elapsed. And if we were to do this, we would find it takes 2 seconds for light to go out and come back. And so it's traveled a distance of 186,282 miles twice, and it's taken 2 seconds to do that. So the average speed is 186,282 miles per second. That's how you get the speed of light, and that's what we would find. Most people assume that it took 1 second to go out and 1 second to come back. But we don't actually know that, do we? All we know is the total time is 2 seconds. It could be, hypothetically, the case that the light zips out and takes all of 2 seconds. Maybe it takes no time at all for it to get out there, and then it takes all of 2 seconds to get back. That's a possibility. Or maybe it's the reverse. Maybe it takes all of 2 seconds to travel out there, and then it zips back instantaneously. And people have said, well, why? Is the mirror affecting it? No, it doesn't have to be the mirror. You could even use another flashlight out there. And when your buddy sees the beam, he turns on the return trip. It could just be that the nature of space is such that light propagates at a different speed this way than it does that way. You'd say, why would it be that way? Well, there are certain crystals that do that, where the speed of light's very different in one direction than another. And it could be that the vacuum of space is like that. The point is, we don't know. And you see where I'm going with this, because if this is the case, if light, when it's moving away from me, is slower, and when it moves toward me, it's much quicker than the average speed, that would solve the distant starlight problem, wouldn't it? because I don't have to send light out to the galaxies and reflect it back. It only has to make a one-way trip. It only has to go from there to here. But so I'm hoping that this will be the case, but hoping for something doesn't make it so. We want to see if we can do an experiment to measure the one-way speed of light. So how are you going to do that? How are you going to measure the speed of light just on a one-way trip and not a round trip? Well, you can't use a mirror anymore. Instead, you got to use two clocks. You got to use one clock to tell you when to start the light pulse, and then another one to record when it impacts. Yes? So I'm going to stand over here. When this clock strikes noon, I send out the pulse, and my buddy's over there with his clock, and when he sees the pulse, he looks at his clock, and you're thinking that'll say, 1 second past noon. Yes? Well, I tried this in my office. I don't have a long hallway, but I have the distance between my watch and the clock on my phone, and I turned on the light right when it hit noon, and the light beam went over to the phone. As soon as the phone, lit up, I said, 12:05. It takes 5 minutes for light to get from my watch to the phone, right? No, you're not buying that? You see what I'm saying? When my clock hits noon, I turn on the light, it goes over, hits the phone says 12:05, 5 minutes. I made an assumption, didn't I? A faulty assumption. And that is, I assumed that the clocks were synchronized. Obviously, the clock on my phone is 5 minutes fast. I do that so I don't miss staff meetings. Okay? So only if the clocks are synchronized could you measure the speed of light this way. And by the way, they have to be exactly synchronized because the speed of light is very quick, whatever it is. We know it's quick. So if that other clock is just a little bit off, you'll get the wrong answer for the speed of light. It could be very wrong. You say, no problem. We'll make sure the clocks are synchronized. That turns out to be very difficult to do with clocks that are separated by a distance. Normally, the way we synchronize clocks is with a radio transmission. In fact, my watch does that. It receives a signal from the radio transmitter in Fort Collins, which is tied into the atomic clock in Boulder. And every night it receives that signal. I never have to set it. It's pretty neat. But it's not maybe exactly synchronized, right? Because that radio pulse actually takes a little bit of time to travel from the source clock to the receiver clock. Radio's fast, but it's not instantaneous. So, maybe what we could do, of course, if we knew the amount of time it took the radio pulse to travel from here to here, we could subtract that off. We could push that clock forward a little bit. Well, how fast does radio travel? You know the answer to that? It travels at the speed of light. Yeah. And so that's the very thing I'm trying to measure. That's the very thing I don't know is the one-way speed of light. We know radio travels at the speed of light because if I have a radio transmitter and a flashlight, they'll hit the wall at the same time. We know that. We just don't know what that speed is. My point is you'd have to already know the one-way speed of light in order to synchronize clocks by radio transmission. Now, I don't worry that my clock is maybe slightly behind the one in Boulder because I'm not trying to measure the speed of light. But if you're trying to measure the speed of light, they have to be exactly synchronized. Some people, for some reason, have thought if you put the radio transmitter in the middle, that'll solve it, right? Because then you send the radio pulse in both directions and both clocks are synchronized to noon at the same time. It doesn't matter what the speed of light is, but in fact it does because that presumes that the speed of light and therefore the speed of radio is the same in both directions. If it's different, then this clock gets set to noon first and that clock gets set to noon second. See, noon there and then noon there. And they're not synchronized. See, so you can't synchronize clocks that way. It doesn't work. One last resort. We'll synchronize two clocks in the same place. That's easy to do because you can see they're both reading the same time at the same time. Then we'll move one of them or both of them to opposite ends of the hallway. Yes? That should work, right? It doesn't, because according to Einstein, motion affects the passage of time. The very act of moving the clock has caused it to become desynchronized from its buddy. Now, it turns out there's an equation that can tell you how much the clock has become desynchronized, and you could compensate for it. And in that equation is the speed of light. Yeah. Isn't that interesting? It's almost as if God doesn't want us to know the one-way speed of light. Here's what the implication of this is. Apparently, it's impossible to synchronize clocks without knowing the one-way speed of light in advance. And it's impossible to measure the one-way speed of light without synchronized clocks. So you see, we're stuck in a permanent catch-22. It is fundamentally impossible to measure the one-way speed of light. It cannot be done because you need to have synchronized clocks, and the only way you can have synchronized clocks is if you already knew the one-way speed of light. It cannot be done. Now, when you have a catch-22 like this, it suggests that the question may be a bad question, a faulty question. And so I'm going to conclude that the one-way speed of light is not actually a property of nature at all, but is something that is a convention. A convention is something that we choose and we all agree to it and we stick with it and it works. Like driving on the right side of the road. That's a convention. We all agree to that and it works. But in other nations, they pick the left side of the road. And as long as they all agree to it, it works too. You see, that's a convention. It's not, it's, if we asked them, well, what, in the universe, what is the correct side of the road to drive on? That question is meaningless because it depends on what country you're in. It depends on where you're at. Or how many, if I had a table that's, let's say it's 1 yard long or maybe it's 3 feet long, which is it? Is it 1 or 3? What's the right answer? Is it 1 yard or is it 3 feet? What's the answer, right? It's both, isn't it? Well, should the number be 1 or should it be 3? Well, you tell me what you want. You would tell me if you're using yards or feet, and I'll tell you what the answer is. The one-way speed of light is like that. We get to choose what it is, and that tells us how to synchronize our clocks. And then when you measure the one-way speed of light with your synchronized clocks, you'll find it was whatever you chose. Yeah. Okay? So the lightning bolt strikes exactly in between these two clocks, and we're going to decide that the speed of light's the same in both directions. We can do that. We're going to choose that, and then the two clocks are synchronized. But if you want to make a different choice, you can do that too, and you can synchronize them differently. That light requires the same time to traverse the path A to M as for the path B to M is in reality neither a supposition nor a hypothesis about the physical nature of light, but a stipulation which I can make of my own free will in order to arrive at a definition of simultaneity. We choose the one-way speed of light, and that tells us how to synchronize clocks. And that quote is by Albert Einstein. Einstein recognized that the one-way speed of light is not something you measure, it's something you choose. Which means I can choose it to be something very different than what most people do. In fact, I can choose the speed of light to be infinite when it's directly toward me and half c when it's moving away. And the reason I pick those two values, it has to average to c. It has to average to the speed of light that's the round trip speed. Okay, but you get to pick the one-way speed, and then the average will tell you what the return trip has to be. And it turns out it's 1/2 c if you make it infinite in one direction, because it's a time averaged. And one of the reasons I choose this is because it solves the distant starlight problem. But another reason is because all ancient cultures implicitly used this definition. They didn't subtract off light travel time because they didn't know what the speed of light was. When you saw something, that's when it happened. And so I'm going to suggest that the distant starlight is solved if we use this. I'm going to call it an anisotropic, which means different directions, anisotropic synchrony convention, or ASC. Using the anisotropic synchrony convention, light takes no time at all to get from distant galaxies to here. And according to Einstein, I'm free to synchronize clocks that way. And the distant starlight problem, therefore, is solved if the Bible's using that convention too. And so that's really the only issue. Is the Bible using this anisotropic synchrony convention, or is it using Einstein convention, or is it using something else? It's using some convention because it's talking about time. So there's some convention there. I think the Bible is using this anisotropic synchrony convention. I'm going to show you why. Well, I already mentioned one reason. All ancient cultures used that. And the Bible is meant to be understood by everybody, not just by modern physicists. But if you take a look at Genesis 1:14 and 15, then God said, "Let there be lights in the expanse of the heavens to separate the day from the night, and let them be for signs and for seasons and for days and years." And later we find this is the sun, the moon, and the stars also, the greater light, the lesser light, the stars also. He says, "And let them be for lights in the expanse of the heavens to give light on the earth." And it was so. It's that last little phrase, "and it was so." What was so? Well, they gave light on the earth. You see, God created them to give light on the earth, and apparently they immediately did, and it was so. That suggests to me that the Bible's using this anisotropic synchrony convention whereby light reaches the observer in no time at all. And according to Einstein, that is a legitimate convention. And by the way, I'm not suggesting that the alternative, that the speed of light is the same in all directions, is wrong, because that's like saying a table, it's wrong to say it's 1 yard long. It's actually 3 feet. They're just two different ways of measuring things. And so I'm going to suggest that the convention the Bible uses allows light to get here instantaneously. It's not a problem. There could be other answers to that, but this is one that works, and nobody's been able to refute it, so I think it's a pretty good model.